Okay, so this is lesson 2.7. So this is solving polynomial equations. So I should note that in this lesson, all you really do is you use the factor theorem to find your factors, and then you just solve for x. So you're just setting your factors equal to 0 and you solve for x. So I figured I don't have to do that because I showed you how to do the factor theorem already. The only difference is once you find your factors, you just set them to equal to x. You set them equal to 0 and you solve for x. So here, we have a similar type of question. We still have to do that, but we have to take it a step further by graphing. So we're going to sketch this polynomial equation, and we have to find the x-intercepts and the y-intercepts to do that. So first thing I'm going to do is I'm going to use the factor theorem because I have to find the x-intercepts. So I have to factor this first. So I'm not going to show you how to do that because I don't want to waste time here. So I'm going to use the factor theorem and I'll show you what I get. Okay, so I finished factoring this, and we have to factor this because we have to figure out the x-intercepts and the y-intercepts to graph the function. But I want to note that what we really did here is we're doing what we're doing in 2.7, just I'm not doing a beginner level question for 2.7, but the concepts we do in 2.7, I'm still doing them here. So basically, first thing I did was I used the factor theorem to factor this. So I figured out that 2 equals 0. So therefore, I know x minus 2 is a factor. So next thing I did was I used the synthetic division to find out the other factors. So once I performed the synthetic division, this is what I got. But this can still be factored. So I brought everything over to this side. So x minus 2 is a factor. And then I wrote this out from this. And I factored this. And when you factor this out, you get x plus 3 times 2x plus 1. So now, this is really what 2.7 is. You're solving for x. So all you're doing is you're setting these factors equal to 0, and you solve for x to find your x-intercept. So x minus 2, that's just equal to 2. This is just equal to negative 3. X is equal to negative 3. And this is equal to negative 1 over 2. You just solve for x. So these are your x-intercepts. And now that we have these x-intercepts, I'm going to sketch. No, sorry, I apologize. Now that we have these x-intercepts, I'm going to find the y-intercept by just plugging in 0 for x, and then I'm going to sketch. Okay, so I erased everything and I just included what we needed. So as you can see here, these are the x-intercepts we found earlier. This is just the equation written out again. We still have to sketch it. And if you plug in 0 for x, you get negative 6, and that's our y-intercept, 0.0, negative 6. So now what we're going to do is you can do this after I solve this question. We have to sketch this. You'll see how you can do this in different ways, but I'm just going to do it this way. But there's no correct way to do it really. I mean in the order that you do it. So first thing I'm going to do is I'm going to plot these x-intercepts. So x equals 2, so we can put that here maybe. This is 2. This is a negative 3, so we can put that over here. And x equals negative 1 over 2. So we can put that here. Okay. So, shoot, my apologies. I just want to include the factors because they'll be important later on. So these were the factors that we got. And we factored this. So, what am I doing? So these are the factors that we got when we factored this. I just wrote them like this. The only difference was they were written horizontally, but same thing. These are the factors we got when we factored this. And you'll see why that's important later. So now we'll plot our y-intercept. So that's maybe down here. Okay, so now we've plotted our x-intercepts and we've plotted our y-intercept. So now what you want to do is, first of all, you want to notice that the order for all of these factors, it's 1. So now we know the behavior of the polynomial at these x-intercepts. It's just 1. So the order is 1. If you don't know what that, wait, no, you do know what that means. What am I doing? We did that last unit. So the order is 1 for all of these. Now, next thing we're going to do, we have to find out the degree of the polynomial, and that is 3, which means the degree. So I'm going to put d for degree. It's 3, so it's odd. And the sign, so the sign of the leading coefficient, it's 2, and 2 is positive, so it's a positive. So since the sign is positive and since the degree is odd, we know that the end behavior, the polynomial is going to start in quadrant 3, and it's going to end in quadrant 1. So it's going to start somewhere here and it's going to end here. So now that we know everything, we can just draw a sketch, and we've solved the question. We've sketched this, and we found the x-intercepts and the y-intercepts. So we're going to start here. Now, since the order is 1, it's going to just go through straight. It's going to go through linear. Then it has to go through here, straight, linear, because the order is 1 there. It's going to go through this writing here, I'm sorry. And now -6 comes before 2, so we know that it has to go down. It has to go through the y-intercept. And then it has to go through 2 as a straight line, and it's going to finish in quadrant 1. So this is a sketch of the function, and in order to do this, we use the factor theorem to factor this. And then after we factored it, we found our x-intercepts by setting our factors equal to 0. We found our y-intercept by plugging in 0 for x, and then we know that the order is 1 here for all these factors, and then we found our end behavior, and then we just sketched. So that's how we solved this question.